Hello everyone. Let's do a quick recap of the topic of sorting that we have covered so far. We have covered two different approaches for sorting. The first approach was by using the sort method call on a list sequence. Recall that the sort method call rearranges items in the original list object itself, so it's going to have an impact on the original list object. The second approach that we covered was by using the sorted function call. Unlike the sort method call, the sorted function call does not rearrange the items in the original list object. It rather creates a brand new list object where you have the items arranged in whatever order that you want to do the arrangement in. We covered a lot of examples for both of these approaches. For example, if you have a list of integers as input, both of these approaches are going to create a list of integers as output in such a way that the integers are arranged in an ascending order, which is nothing but increasing order. If your input is a list of strings, then you're going to get the output as list of strings which are ordered in alphanumeric manner. Similarly, we covered examples for list of Boolean values. In today's lecture, we are going to cover more complicated examples of sorting. Instead of having a list of primitive values, what if I had a list of tuples? Here is an example for you. I have a list called names, which contains 3 items. Each of those items is a tuple. Each tuple entry contains 2 items. The first value here is going to be the first name and the last value here is going to be the last name. So now when I call the sort method call on this list, what will happen is Python will do the sorting by using the first element in the tuple entries, which is going to be the first name here. So since we order by first name, you're going to get Alice Clark first, then Bob Adams, finally you'll get Catherine Baker. What if I wanted a little bit of flexibility here in terms of what the sorting needs to be done based on? What if I wanted to sort by last name instead of sorting by first name? Most of you might know that sorting by last name is more common than sorting by first name in general for anything. What if I wanted to sort by the length of the name instead of considering the first name or the last name ordering for the sorting? The complicated thing about sorting is that when you try to write your own function to perform the sorting, it's really tricky to handle many of the cases when it comes to sorting. Sorting by itself is an extremely complex topic. People do even research on how to come up with the best solution for sorting techniques. So we are not going to write a function to perform sorting from scratch. Instead, we are going to leverage a named keyword argument that you can pass to the sort method call and to the sorted function call. The name of the parameter is key, kind of a bad naming because this has nothing to do with the dictionary key at all. Just that this parameter name for the sort method call and the sorted function is called as key. What should we pass as argument to this particular named keyword parameter key? We are going to pass the function object, which is going to let us define a function which defines which particular column you want to do the sorting based on. For example, we can define a function called extract that takes single tuple as argument and it returns which value inside the tuple that you really care about. For instance, if we want to sort by last name here, we can just return name underscore tuple of 1. What now will happen inside the sort method call is that you're going to order your original list of items based on last name. So you're going to get Bob Adams first, and then you're going to get Catherine Baker, and then finally you're going to get Alice Clark over here. Similarly, you can change your extract function to consider length of name of tuple of 0. which is going to consider the length of the first name. So now if you run the sort method call by passing extract as the argument to the keyword parameter key, you're going to get the output as Bob Adams first, Alice Clark next, and Catherine Baker last. Let's go through a demo problem for this particular example. Instead of using list of tuples, I'm going to use a list of dictionary for my example. Let's say that we have a hurricanes list of dictionary. Each dictionary contains 3 key value pairs. The first key value pair is going to be name of the hurricane. The second key value pair is going to be the year in which the hurricane was formed. And the third key value pair is going to be the speed of the hurricane here. When you try to call the sorted function on a list of dictionaries, let me go ahead and demonstrate that one more time. So you're going to get a type error, and type error is going to say that less than is not supported between instances of dictionary and dictionary. Let's try and understand what exactly is meant by this. I'm going to add a new cell here. Let's try to first read hurricanes of 0. Okay, that's working. What if I read hurricanes of 1 over here? That's also working without any issues. Let's try to do hurricanes of 0 less than hurricanes of 1. What do you think will happen when you try this? Notice that you're getting the exact same error saying that less than is not supported between instances of dictionary and dictionary. Why is that the case? That's because you're trying to compare a dictionary object with another dictionary object. Python doesn't really know which one of those fields is important to you. So we need to be explicit about what exactly we care about when it comes to sorting. So the reason for sorted function call failing is also the exact same thing. That's because you cannot compare hurricanes of 0 with hurricanes of 1. Let's go ahead and define some get functions so that we can tell sorted function what exactly we care about. So the get underscore year function is really simple. It's just going to take as an input a single hurricane, and it's going to return the year value of that particular hurricane. So I'm going to say def get underscore year of hurricane is going to just simply return hurricane of year. So recall that you can do a index lookup just by saying dictionary name of key. So let me go ahead and execute this function. And the next note here says call sorted function using get underscore year function. So recall that you'll have to say sorted of hurricanes, and then you're going to say key equal to get underscore year. Notice that now we are able to do the sorting. So let's take a look at the original list entries here. I'm just going to display hurricanes just above this. So the original list contains 3 dictionaries. Year 2000 comes first, then 1980 comes, and then finally you have 1990. Notice that in your sorted output, you're getting 1980 first, 1990 next, and 2000 last. This is a very handy way of doing the sorting. In your function where you're doing the column value extraction, you can also perform transformations. For instance, let's say that I want to do a reverse sorting based on the year instead of doing the ascending sorting. I could just say return minus hurricane of year, and what that's going to do is it's now going to give me the list of dictionaries sorted in the reverse order, where I have 2000 first, 1990 next, and 1980 last. You can think about any number of transformations here. Another way for you to do a reverse sorting would be to use the named keyword argument called reversed. So reverse here when set to true is going to reverse whatever you're doing. So right now I'm returning negative of year. So if I reverse that, I'm going to get ascending order sorting here. Notice that right now we are getting ascending order sorting. Right, let's define one more function here, which is the get underscore speed function. So I'm going to say get underscore speed of hurricane is going to be hurricane of speed. Right, I have one more example list of dictionaries here. Notice that I removed the speed for the third hurricane dictionary. I did that purposefully so that you can see what will happen when you call the sorted function, you bypassing get underscore speed as the argument to the key parameter. So let's go ahead and do that. So I can say sorted of hurricanes, and I can say key equal to get underscore speed. That's going to make Python complain. Why is that the case? It's not able to look up the key speed for this particular hurricane because that key doesn't exist, correct? Recall that you can use the get method call instead of indexing, and that you can pass a default value out of the get method call whenever you're trying to look up a value inside a dictionary. For instance, I can say that the default speed of hurricane is 0 just to deal with the data entries which don't have complete information. Let's just assume the speed of a hurricane is 0 if it was not defined previously. So let me go ahead and rerun the get underscore speed function. Notice that now we are able to sort the list of dictionaries here. Why are we getting hurricane C first? Recall that we added 0 as the default value. So 0 comes before 100, which comes before 150 over here. Right, this is going to be the final example for today's lecture. We are going to see how to pass string method to the sorted function over here. So I'm going to try to sort a list of string values. Recall that when it comes to capital letters and small case letters, in any programming language, capital letters come before small case letters. So you're going to get capital A, capital C first, and then small b, small d. What if we wanted to change how this is happening over here? Let's say that we want to do the sorting immaterial of the letters casing here. So we can try and pass the string.upper method call as the argument to the parameter key here. So I'm going to say str.upper, and that's now going to force the list of values here to be sorted without considering the actual case of the letter. How is that? We are going to convert every string into uppercase characters. If that is the case, then capital B comes before capital C. So that's how you get this arrangement. I'll wrap up today's lecture here. Please make sure to experiment more with both the sorted function call and the sort method call to understand how the named keyword argument key works when you pass the function object. So before I wrap up, I just want to mention one quick thing here though. Sorry about that. I missed mentioning that earlier. Let's talk about how many times are we calling this get underscore speed function. That's a trick question, right? That's because we are not calling it at all. How exactly are we using it then? We are using it by passing as a function object reference to this particular parameter. So what if I add a debug statement here saying calling get underscore speed? Let's see how many times the get underscore speed function gets called. Notice that it's getting called 3 times because we have 3 data entries over here, and I can try and print for what hurricane it is being called. So I can say that we are calling it for the hurricane, and for every hurricane you are going to call the get underscore speed function. That's not done directly, it's done indirectly because you are passing the function object as a reference to the named keyword argument key here. And that's going to be true with all of the sorted function call that we covered for all of these examples. All right, now I'm truly wrapping up this lecture video. That will be it for today's lecture.